Welcome viewers. In this video we'll see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We'll see the statement of the problem. A coil of 20 ohm resonance have an inductance of 0.2 Henry and connected in parallel with a condenser of 100 microfarad capacitor. So one coil with 20 ohm resistor and 0.2 Henry is connected in parallel with the capacitor 100 microfarad. Calculate the frequency at which the circuit acts as a non-inductive resistance of R ohm. Find also the value of the resistance. So R1 given as 20 ohm. We need to find the R value when it is act as a non-inductive resistance. So we'll take this is the R1. L is 0.2 Henry, C is 100 microfarad, that is 100 into 10 to the power minus 6 farad. Now we'll see the diagram. So this is the given diagram. The applied voltage is E. This is a non-inductive. It's a coil with the inductance L and resistor R that is connected in parallel with the capacitor. This R value is R1 value is already given. Now we need to find the R value at the frequency at which act as a non-inductive resistance. The circuit is given to be acting as non-inductive resistance. This means that the circuit is at resonance. The meaning of non-inductive resistance is resonance. That is, inductive reactance and capacitive reactance are equal, got cancelled. The circuit is act as only resistance under resonant condition. So the resonant frequency is F0 equal to 1 divided by 2 pi square root of 1 divided by LC minus R1 square divided by L square. This is a resonant frequency. We'll take this equation number 1. So at resonance condition, Y equal to R1 divided by R1 square plus XL square. You take equation number 2. This is the resonant condition. Now substitute the values. In equation 1, we will substitute the value and find the resonant frequency. 1 divided by 2 into pi square root of 1 divided by L. L is 0.2 into C value. C is 100 into 10 to the power minus 6 minus R1 square 20 ohm divided by L square 0.2 square. So while simplifying we got 31.83 Hz. The resonant frequency is 31.83 Hz. So the condition given is non-inductive resistance. So that means the resonance. That is the meaning is the circuit at resonance. Now we calculated the resonant frequency. Now we'll go for the further parameters. So one more formula, the admittance Y equal to R1 divided by R1 square plus XL square. This is under the resonant condition. So Z equal to 1 by Y, that is equal to R. Under the resonant condition, the impedance is only resistance value. That Z equal to R. Z is nothing but 1 by Y. This admittance and impedance both are inverse, both are reciprocal. So that meaning is Z equal to R equal to 1 by Y. Y value is already available. 1 by Y means reciprocal. R1 square plus XL square divided by R1. Right? Y is there, so that we can write 1 by Y. Now we'll substitute all the values. R is 20 square R1 plus XL square is nothing but 2 pi FL divided by R1 is 20. So this FL value also substituted. 2 into pi into F is 31.83, what we calculated, resonant frequency. Inductance is 0.2 divided by 20. So while simplifying we got 100 ohm. So this is nothing but impedance. At resonant condition, impedance is nothing but only resistance, R value. That is equal to 100 ohm. So finally we calculated the resonant condition. Under resonant condition, the resistance value is 100 ohm. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.